So guys, yesterday that we had some introduction about the data science, and we have discussed about the data science. And we know that there are multiple disciplines that we have to understand inside the data science, that is the statistics and machine learning and different programming tools that we can come across. As a part of it, I just wanted to kickstart the sessions from today itself, starting from the statistics. Okay, so before I'm going to kickstart the presentation, I just wanted to go ahead with a normal explanation kind of stuff about the statistics. Okay, so then we can go ahead slide by slide. Fine. So I just wanted to tell you something like what exactly is the statistics is all about. See, statistics is something just like an estimation. Okay, statistic itself is not a complete 100% result that we are going to get. Rather, we can say that it is an estimation of what we are expecting. Statistics is something collecting the data and analyzing the data and getting the conclusions out of the data. Okay, data collection, comma. We understand that a statistics is a kind of data collection, data analyzation, and getting some conclusion out of it. Okay, getting some conclusions out of it. That is what we generally call them as data inferences. Okay, data inferences. Now, this is what about the statistics. And coming to the another part, when we are talking about the statistics, we need to understand whatever. See, there are different types of applications in the statistics, of course. Let us keep that one apart. But for main thing, when we have certain data, we need to identify certain measures. So as a collection of the measures, we have a different types of measures. Something like measures of central tendency, measures of spread, okay, measures of anyone shape. Why? Because see, when we have the data in hand, okay, it is always important to understand the center point of the data, means average. Okay, and also it is always required to understand how spread the data is, or how much variable the data is. Okay, and coming to the measures of shape, we need to understand in a pictorial representation, okay, or in a graphical representation, how the data looks like, right or wrong? Okay, generally we do call it as a visualization. This is how it goes. So let us go through the presentation, and today let us complete at least measures of central tendency. Okay, let me go ahead. So statistics, let me just open up this one. So guys, here, what is statistics? It is a methodology for collecting and analyzing, interpreting and drawing the conclusions from the information that we know that. And there are different types of statistical methods. How do we carry out a research? Okay, very first thing that we need to carry forward is the design. First, we need to plan and we need to carry out certain kind of study or an understanding about the data on which that we are applying some statistical applications. And then description. We need to describe the data, like summarizing and exploring the data from out of it. and inference, making predictions and generalizing about the different phenomena represented by the data. Means we need to get some conclusions, nothing more than that. Okay. So, coming to the applications of statistics, we have different applications of the statistics where we could possibly get some solution out of it. For example, coming to the agricultural sector, is a new grain seed or the fertilizer is more productive? For example, let me say this is something like a testing of a farm field where one particular farmer have used one particular type of a fertilizer in the last year, and where today, okay, he has taken the another fertilizer where he just wanted to compare both of them. Okay, where if at all, if the latest fertilizer giving the more production, okay, where he wants to go ahead with the latest one, or if the previous fertilizer is giving the more production, he wanted to go ahead with the previous fertilizer. So we can understand, okay, while we are choosing the options, we can make ourselves choose the option using the statistics. Coming to the medical problem, we know that most of the medical analysis relies only on the statistics, right or wrong. Whatever you take, whether it is going to be a blood sugar or whatever the test analysis or the samples, everything based upon the medical analysis is going to be statistical related. So what is the right amount of dosage of the drug for a treatment is required? Why? Because the tablet which is going to be prescribed by the doctor is not same for everyone. Okay, so the political science, how accurate the polls, and economics, what will be the unemployment rate next year, a prediction. Okay, technical problem, how to improve the quality of the product. Okay, so can you please tell me any other applications of this? Why? Because I have just listed only five. Okay, can you please tell me, can you please first name the industry? I'm not talking about the agricultural industry. I'm not talking about the medical, political, and economics. Can you please? Yes. Arun Krishna is okay. Mega is saying like law and order. Arun Krishna is saying education department, and okay, good, Mega. That's good one. Okay, Mega saying like we can automate the court hearing. Okay, by making this involved in the law and order. Okay, which is the government sector. Okay, otherwise the legal sector that we can say. Finance, Ankatesh, very good. Finance. Vanaja, insurance. Okay, Kiran, sports, excellent. Sports. See, in the sports it is already existing. When you are watching a cricket, okay, you can see how, I mean, whether the batsman is out or not. Okay, whether he crossed the line before he is going to complete the run. Okay, I mean, every time they are going to zoom it and show it for us. Okay, Sunil Kumar, business. Which kind of business that you're talking about? Banking, yes, banking. Okay, this is expectation by locality. That's right, Sanjeev. Okay, trading, Namrata, right. Okay, in trading there are many stock prediction softwares are there. Okay, so implementing this one into that will always give us very snapshot of what exactly we are doing. So these are all the different types of applications that we can go across, okay, based upon the statistics. And coming to the basic concepts, see, the data always will be in two different forms. One is population and another one is sample. Coming to the population, a population is none other than the collection of all individual items, okay, which is going to be considered in the statistical study. Okay, sample is none other than a sample of items from that population. Okay, so we should understand that whether when we are solving any particular problem, whether we are going to select the population data or the sample data. Okay, in sports, okay, Megha is asking like in sports how this statistical analysis is being used. See, generally analytical services and all these things are being used, by looking. lot of graphics. BCCI is using a lot of things for the cricket and all stuff, and not only that one. Why? Because everything is in sports. Everything is managed while it is in the game. Everything is managed through the video. Okay, and also they are using augmented reality and virtual reality. They did not implement the virtual reality yet. Till now, so far, they are using the augmented reality. That's why you can see many times, okay, in a cartoon kind of format, and they will show you the outline of the ball coming near to the bat and all stuff. Such a kind of analysis will be done through the video. Okay, apart from that one, they will predict, okay, like prediction in the sense, before they are going to start the match, okay, what are the winning probabilities and everything. All these things are comes under the sports guide. Okay, it is not about the cricket, it is about any of the other Olympics medals or whatever it is. Okay. Yeah. Even astronomy is another field, right? So there are different types of statistics, as I said, descriptive and the inferential. Okay, in those respective descriptive and inferential, okay, this is the main thing that we are trying to understand in the statistics. See, when you know the descriptive and the inferential methods, you're good with statistics. That's it. But there are a lot of things to learn in these two different stuff. So first, let us go ahead into the descriptive stuff. Before we are going ahead into the descriptive stuff, we need to understand how a problem should be resolved. Okay, when there is a problem, we need to first define what kind of data that we are going to accumulate. Are we going to accumulate a population data, or are we going to accumulate a sample data? Okay, so first, whatever the data it is, you have to first collect the data. Okay, collect the data and do the descriptive statistics. Okay, okay, do the descriptive statistics. So use proper statistical methodologies, okay, and then report the results. All these things together, okay, we can call them as statistical analysis. So many of the people used to ask me one common question: okay, if this is going to be the statistical analysis, then what exactly a data science is going to do? When you are working with this statistical analysis, okay, if you are going to implement a machine learning algorithms, and if you are going to increase, if you are going to implement, okay, some programmatical tool or a software in order to, okay, and analyze or all this stuff, okay, so then this kind of set, this entire set using by one particular individual are, they are called as data scientists, and they have named as a data scientist. Okay, using the statistical methodologies along with the machine learning capabilities with a programming tool. Okay, so now variables. Coming to the variables, okay, we have different types of variables. One is qualitative, one is quantitative. Okay, qualitative: nominal, ordinal, binary. See, what is the difference between the qualitative and quantitative? Quantitative is numerical, okay, whereas qualitative is categorical. Okay, categorical means non-parametric. Quantitative, numerical means parametric. Okay, so there are three different types of qualitative variables. One is nominal, ordinal, binary. When you say nominal, it says gender, race. When you say ordinal, depends upon the ordered series, where I can say like performance report, your school performance report, A grade, A plus, B plus, something like that. Okay, and binary, coming to the binary, we know that variables with only two options like pass or fail, okay, yes or no, something like that. Okay, coming to the quantitative, okay, we have two more variables: discrete and another one is discrete and continuous. Okay, so coming to the discrete and continuous, we need to understand what is discrete and what is continuous, right or wrong? So when I say discrete, I already um, told you like these two are numerical stuff. Okay, discrete represents a number or a data uh, which can be a result of a one particular count. For example, let me say how many number of vehicles are traveling on this road. How many number of vehicles are traveling in this road? Okay, that will change every minute. Okay, so every minute there will not be a constant number every 1 minute or 2 minutes or whatever it is. So the unexpected number, okay, which can be counted, can be considered as a discrete. And the coming to the continuous is something like a measurements. Let me say, uh, measurements comes under height, length. If I ask you like how many numbers between 0 and 1, they are uncountable. Okay, 0.001, 0.0001. So infinite numbers are there in between. So hence we need to consider these continuous items. Okay, together we can call it as a continuous measures. Okay, these are the two different types of qualitative variables. Okay, quantitative variables, I'm sorry. So another type of quantitative variables, apart from quantitative and the qualitative variables, we have two more different types of variables. One is a dependent variable and another one is an independent variable. Okay, dependent variable, we know more about this. Dependent variable is none other than something that, okay, which is completely depending upon another variable. So depending upon the another variable, this will give you some result, obviously. So independent variable is the one which is being controlled by an experimenter. Means I mean like whatever the value that we are going to provide, that is going to be considered while we are doing any sort of calculation. Okay, for example, let me say I just wanted to try to understand. See, I will tell you one statement. You all has to tell me which is dependent and which is independent. Okay, the more number of hours, the number of hours of study is leading to a student success in the examination. So I have two variables here. Okay, number of hours student spent, each student spent, and the marks of a student, number of hours each student spent. Can you please tell me which is dependent and which is independent? I will ask you first. Okay, can you please tell me number of hours spent by each student comes under which variable? Is it dependent or independent? Right, Namrata? Dinesh, right? Arun Krishna, right? Narayana, no. I'm going to repeat once again. Vanaja is asking to repeat one more time. I'm asking you two variables. Okay. See, one variable is number of hours student, each student spent. Okay. And marks by each student is the second variable. Okay. Sanjeev, no. Suresh, no. I asked you which type of variable is hours, I mean, number of hours spent by the student. Number of hours spent by the student will become independent variable. Why? Because based upon number of hours, the student result will be depending upon. Hence, the student marks should be a dependent variable. Right or wrong? I will, I will, I will let you know one more thing. Okay. No issues, Mega. Go ahead. I will let you know. I will give you one more example. Okay. I will give you one more example right now. Okay. Let me give you amount of a fertilizer and production of the farm Which is independent, which is dependent? I just wanted to know which is dependent here. Now, I'm giving you two variables. Let me just write them. Otherwise, see, amount of fertilizer used, production of the farm. Which is independent, which is dependent? Okay, number one is okay, Narayana, that's right. Who else? Suresh, tell me the answer. Dinesh, one in. Okay, right. Good, good, good. Good, Dinesh. Right. Right, Sanjeev. I want all of you to answer both. Suresh, what's the answer? Ramkoti, right. Kiran, super. Vanaja, wrong. See, amount of fertilizer is going to be independent. Why? Because if the amount of fertilizer if I'm going to use more, the production will be more. Right or wrong? If I'm going to use the less fertilizer, less amount of fertilizer, the production will be down. So which is dependent and which is independent? You tell me, Manaja, can you please tell me this? Am I right or not? Hmm? Okay. So this is how that we need to check. Okay, how we need to work on this one. Okay. So now, okay, that's fine. Not an issue. Okay, fine. Now let us go back. I just want to okay, now we understood this one. So here we do have the descriptive statistics, which is measures of central tendency, measures of spread, and measures of shape. Let me discuss about the measures of central tendency. Okay, in the measures of central tendency, we have a mean, a median, and mode. Okay, mean, median, and mode. Here you do have measures of shape. We will discuss later. Okay, I just want to concentrate only in the today's session, which is going to be the mean, median, and mode. Okay, so I will discuss this part. Hence, before that, let me just show you something like this. So guys, let me open the Excel sheet. Okay, I have some value, something like this. Okay, like some 10, 20, 40, 50, 30, 60. Okay, so if I just wanted to see the centrality of the given data can be measured in a three different ways, which is mean, median, and mode. Okay, so I just want to put a one more stuff, that is 20, and I want to put one more stuff, that is 40. Okay, 40. So this is the data. If you can count, I don't know like how many they will come. Okay, just want to show you something here. Okay, so how many values are there? 8 values are there. 8 values. Okay, so if I just wanted to count the list of all numbers, I need to perform something called a mean. Do I have any mean formula? No, I don't have any mean formula. Can I have average at least? Yes, I do have an average. Okay, average itself, it is returning arithmetic mean. Okay, let me use the average. Average of, select all these numbers. So this is going to give you the real mean value. Okay, this is a mean. Agree? Agree the value? The value is, okay, the value is mean. Got it? The resultant value is going to be the mean. So now what I just wanted to identify the median. Okay, so guys, how do we identify the median? Coming to the median, equal to median. Okay, select all this stuff. That's it. But is this the right median? I will discuss everything. Okay, many of you might have confused the way that Excel is giving us the answers. Okay, do not confuse that. Okay, there is another way of understanding the median with this. Okay, do not get confused. I will give you a clear clarity. Okay, and also mode. How to identify the mode? Equal to mode of 20. Okay, so guys, let me just discuss with you what exactly mean, median, mode. Okay, and are we getting the same kind of values based upon the formulas that we do have? Okay, let me just discuss about this part. Mean is arithmetic mean. Okay, where you need to identify 10 plus means it adding and sum of all the numbers divided by total number of values plus 40 plus look, see, first listen to the session. Okay, then if I ask you any questions based upon the session that you have listened, please let me know the answers. Okay, do not estimate or do not tell whatever the formulas you know. Understand? 50 plus 30 plus, okay, 20. I already told you that it is all sum of all the numbers together divided by total number of values. Please try calculating first that one. Plus 60. Can you please tell me what is the total? 30, 70, 120, 120 and 150, right? 150, 120, 270. 270 divided by how many number of values? 8, equal to what is the answer, guys? Immediately, if I'm going to calculate the number, 270 divided by 8, it's going to give us 33.75. Are we good? Are we good? Next one, median. So guys, median, how it works? We have the value somewhere like this: 20, 40, 50, 30, 20, 40, 60. Okay, so in median, how we need to work on is different. Okay, so median always take before you are going to, very important step that you have to remember, when you are going to calculate the median for one particular set of numbers, you need to keep all those numbers in an ascending order or a descending order either. Let me just keep all these things in the ascending order. 10, 20, 20 one more time is there, 30 is there, 42 times is there, and then 50, and then 60. Okay, then if the total number of values is going to be even, then take the average of the two values, middle two values. Okay, if the total number of values is odd in number, then you take the middle value. Okay, here the total number of values is 8, hence I'm going to take an average of these two values, which is 35. Okay, next, in the same way, I just wanted to work out with the mode. Okay, coming to the mode, generally mode we can identify it for the multiple iterations which number is going to be a repetitive number. We can observe there are two different numbers. One is 20 and another one is 40. 40 is repeated and 20 is repeated. Okay, so which is going to be the answer now? For example, if we have only one number which is repetitive, which is only one number, that is 20, the mode is 20. But otherwise, if I have one more value which is 20, the answer is 20. But here I have only 20 came for two times, 40 came for two times. So almost equal in number, right? So most of the time it will try to prefer 20 and 20 it became. So try to prefer the 20, okay, if not a 40. Okay, but here in our Excel sheet, almost all the terms are good except the mode value. Okay, why? Because this is how the mode works. And I just want to show you one more thing, guys. For example, if I'm going to expand this part, okay, look, I'm going to make 40 here. More change it to 40. Look at this. Because 40 is 3 times, 20 is just 2 times. Okay, I'm going to make 20. Why 20? Why? Because the first one and first serve. Got it? Sometimes some people say, let us take the average of those two mode values. Okay, sometimes some people say, let us consider two mode values together. Okay, so this is how it would become. But we have understand what exactly the mean and the median and mode values are. Are you understanding? Are you with me, guys? Every one of you. So if you take an arithmetic mean, it is none other than, okay, it's an arithmetic mean means sum of all the numbers together divided by total number of values. The systolic blood pressure of 7 middle-aged men, okay, were as follows. We have different values over here, and let us sum and divide by total number. Okay. And one more thing is, if the sample data is arranged in the increasing order, then the median is the middle value, and if n is odd number, if it is the even in number, then we will take the average of the middle two numbers. Okay, the mode is the most commonly occurring value. Yes, so we have different examples over here. You can take a look at this. 113, 124, 124, 132. What is the mode for this, guys? Tell me. What is the mode value? Arun, Syed, 124, right? Okay. What is the median? Before you are going to calculate the median, you have to keep all the numbers in the incremental order. Anyhow, everything is there in the incremental order. You can see the middle value as 132. Hence, the median should be considered as 132. Okay, right. Right. So in the same way, we do have even this example. Okay, we always have to rearrange the data in the numerical order, whether it may be a descending or an ascending order. Okay, the median is half the way between the two readings. Hence, why? Because we have the even in number. The total number of numbers are even in number. Okay, and what is the mode here? 274. Right. Excellent. Right. What is the median here? Average of 274 and 292. Right or wrong? Right. So we understood what exactly the mean is, or what exactly the median is, what exactly the mode is. Okay. Now, okay, Narayana is asking what is the use of mode. Guys, we will have a data, customer data. Okay. Customer data, each and every customer is coming from different cities. Okay, one customer is coming from Hyderabad, another customer is coming from Bangalore, Pune, Delhi, Chennai. Okay, I will assign each and every one a one particular value. Hyderabad 1, Chennai 2, Bangalore 3, something like that. Okay, if I go ahead and check the mode value of all the values that I'm going to find out there, if I'm going to get 1, what that means, I have more number of customers from the Hyderabad. Can I consider it or not? Narayana. Narayana. Can I consider that or not? Right. So this is a kind of stuff that we can always identify from the mode. So now I'm asking you a question like, guys, I'm asking you a question. What is the best measure of centrality? We know that mode is not the best measure of the centrality. Of course, then we will take the mode out of the competition. Okay. And let us identify whether it is the mean and median, which is the best measure of centrality. Centrality is means identifying the center of the data. Right or wrong? Huh? What is the best measure of centrality, guys? See, if I am going to take out all the stuff, if I'm going to make some 1000 over here, okay, what will be the mean? 120. No, let me just take out this 20. 10, 40, 50, some 1000. What is the mean value? Please tell me. Otherwise, I will put it side by side. Otherwise, what is the mean value? It is 550. Huh? What is the median value? What is the median value? 45. There is a huge difference, right? Hmm? For example, let me give you something like this. 20, 30, 10. Okay. Can you please tell me the mean of all these values? Fast. Mean is 615. Excellent, Sunil. What about median? What about median? In order to count the median, you have to keep everything in the incremental order. I already told you 10, 10, 10. How many 20s are there? 20, 20. Okay, 42 times is there. Okay, 42 times is no, one time is 30. Okay, and 42 times is there, and then 51 time is there, and then 1000. Okay, 1, 2, 3, 4. Okay, and here 1, 2, 3, 4. You can take the median of these two. Okay, hence it is going to be 25. Right? What is the so much difference that you can see the measure of centrality between the mean and median? If you take even the mode, what is the mode value? 10. Huh? Right or wrong? At least mode is almost near to median, but mean is not at all near to median. Let me just reveal you one important secret here. Shall I tell you what exactly this data is? This data is none other than I have the students. I have 10 students in my class. Okay, I kept a test. I kept a test for 50 marks. Okay, and they are all the results. Okay, the above all the results of the test. Got it? So does anyone have the 1000 out of 50 marks? No, right? Huh? Oh, okay, fine. 123. Even though if it is 123, it is a user number. Okay. So this is an outlier. Instead of 10, it was mistakenly the data was happened or whatever the reasons might be. Okay. So when you see, when there is an outlier, generally this is called as an outlier. When there is an outlier in the data, okay, the mean is getting inclined towards the outlier, whereas the median is not getting inclined. Right or wrong? So the best measure of centrality is median when it's compared to either mean or mode. That is what I have discussed here. You can take a look at this one, guys. Large sample values tend to inflate the mean. This will happen if the median is not influenced by the large sample values and is a better measure of centrality. Okay, got it? Just remember only these 2 points. I have even other points also. Whenever you have a mean median mode equal, then the data is said to be symmetrical. Okay, then the data is said to be symmetrical. Did you understand, guys? Did you understand my concept of choosing the median as the best measure of centrality? Everyone has to tell me whether did you understand or not. If you don't understand, tell me no. I will re-explain again. I don't mind re-explaining. Okay. Okay, I hope that you all understood this. Okay. So this is what I thought of discussing today, which is all about the descriptive statistics, which comes under measures of central tendency. That's what I have discussed. I have more descriptive statistics to be covered, okay, which I will be covering in the next upcoming session. Okay. Okay, guys. See you. Thanks for attending the session. Thank you all.